Find the zeros and give the multiplicity of each. List the zeros in order from least to greatest. Alright, so I have the function f of x equals 3x to the fifth minus 30x to the fourth plus 75x cubed. Now, there is a common factor among each of these terms, and so we could go through the process that we've established in the class of graphing it and start getting the zeros from the graph, the initial real zeros that is. Or, since there's this common factor, perhaps we can find an easier way by using some strategic factoring. So each of these coefficients is divisible by 3, so I can pull 3 out. And each of the variables has a factor of x cubed in it, so I can pull that out. And if I divide 3x to the fifth by 3x cubed, that would leave me with x squared. Similarly, this middle term would be negative 10x, and lastly I would have plus 25. And let's see if we can get these remaining quadratic to factor. So if I take two things to multiply to x squared, that's x squared, multiply to 25, but then add to negative 10, it looks like that would be negative 5 twice, which means I actually have a 0 of x minus 5. Well, that's the factor is x minus 5. The 0 is positive 5 twice. So what that means is my zeros, the unique zeros, are 0 itself and positive 5. And I get those from taking the factors and setting those each equal to 0 and solving. And I don't really need to pay attention to the squares and the cubes here, because the first thing you would do in solving these is take the cube root and the square root of both sides, ultimately leading you to just this, which is the factor. So those are my zeros. Now the multiplicity. The multiplicity comes from the degree of that 0. So x cubed tells me I have the 0 of 0 itself 3 different times. So that's a 0 of multiplicity 3. The 0 of positive 5 occurs twice, so that's multiplicity 2.